and do the join operation, and transfer the join result back to wherever it should be stored, and store it into the right partition. So of course we do not transfer a single tuple at a time. We accumulate some number of tuples in a temporary table and transfer that in a single message. So we pipeline this communication and computation such that we fully utilize CPU and network bandwidth. If you use 10 gigabit Ethernet, which gives you about 1 gigabyte per second bandwidth, we fully utilize its entire bandwidth. If you use InfiniBand, which gives you about 5 gigabyte per second, we can utilize about a little less than half of it, which is about 2 gigabyte per second, which is far better than any of existing big data analysis platforms. So while we do this distributed computation all automatically behind the scene, we make it possible for users to control this communication pattern a little bit by the ordering of the table in the rule body. So if you have bar table first, we transfer the tuples in the bar table to where the matching tuples are stored, as in the previous case. But if you reverse it and have POX table first and then bar table, we transfer the tuples in POX table to where the matching tuples in bar table are stored. So going back, in the previous case, when we do the distributed join operation, we know the value of B already, which is from bar table. So this is in the partitioning column. So we know exactly where the matching tuples are potentially located. So we know where to send it to. But in this case, we do not know the value of A until we actually do the join operation. So we need to broadcast the tuples in POX table to the rest of the machines. Depending on the relative size of the tables, this may or may not be better than the previous case. And the relative size of the tables are something that programmers are typically aware of. So we let the programmers to determine the communication pattern by the ordering of the tables. But of course, it's potentially possible in the future for the social runtime system to automatically optimize this and minimize the communication volume. So let me use the same rule here to describe how we make use of multiple cores. So given two machines, we partition the tables into two pieces. But for each partition on each machine, is further divided into sub-partitions. And given a socialized rule like this, we create multiple evaluation tasks, as many as the number of sub